Hello dear student, myself Prof. Sokborejke. Today we learn new topic electric potential due to point charges. Next point we can discuss electric potential due to electric dipoles. And third point we can discuss here electric potential due to system of a charges. These 3 points we can discuss one by one. Firstly, we can discuss here first point, an expression for electric potential due to a point charge. See this diagram. Consider a point charge plus q located at point O here. Let a positive unit charge be brought from infinity to A as shown this figure. Point capital M is a intermediate point on this path such that OM is equal to x. Is OM is equal to x here. Then the magnitude of electrostatic force on unit positive charge at M is given by, here we can write this, F is equal to 1 upon 4 pi epsilon naught into Q upon x square. Consider equation first here. It is directed away from O along OM for infinite similar displacement dx from M to N. See this diagram. M to here M to N. The amount of work done is given by amount of work done. Then we can write dw dw is equal to minus f into dx. Here the negative sign appear as displacement is directed opposite to that point of force. Then we can calculate total work done is displacing the unit positive charge from infinity to A is given by, we take integration of equation w here w is equal to integration changes from infinity to small r minus f into dx. Then we know that from equation first the electrostatic force is equal to 1 upon 4 pi epsilon naught into q upon x square. Then we can write this integration changes infinity to minus r minus infinity, integration changes from infinity to r minus 1 upon 4 pi epsilon naught q upon x square into dx. Consider equation number 30 here. Then we can write this equation w is equal to minus q upon 4 pi epsilon naught integration changes from infinity to small r 1 upon x square into dx square, because here this constant term we can write outside the integration. Then w is equal to minus q upon 4 pi epsilon naught integration changes from infinity to r 1 upon x square into dx. Then 1 upon x square we can write x raised to minus 2. Then this equation we can write w is equal to minus q upon 4 pi epsilon naught integration changes from infinity to r. Here replace this term 1 upon x square, we can write x raised to minus 2 x raised to minus 2 into dx. Applying rule of integration, w is equal to minus q upon 4 pi epsilon naught into x raised to 2 plus 1 upon minus 2 plus 1. Then upper limit is small r and lower limit is infinity. then W is equal to minus q upon 4 pi epsilon naught into x raised to minus 2 plus 1, this become minus 1, and upon minus 2 plus 1, this become minus 1. Then we can write in this way: W is equal to minus q upon 4 pi epsilon naught into x raised to minus 1 upon minus 1. Then integration upper limits is minus r, in upper limits here small r, and lower limit is infinity. Then W is equal to minus q upon 4 pi epsilon naught. We can write this term in this way: uh, x raised to minus 1 upon minus 1. We can write this minus 1 upon x. Then this equation W is equal to minus q upon 4 pi epsilon naught into minus 1 upon x. Here upper limit is small r and lower limit is infinity. We can write this q is equal to, here minus minus become plus, then we can write this equation in this way: W is equal to q upon 4 pi epsilon naught 1 upon x. This upper limit is small r and lower limit is infinity. Put these upper limits and lower limit in this equation, we get W is equal to q upon 4 pi epsilon naught into 1 upon r minus 1 upon infinity. Then W is equal to q upon 4 pi epsilon naught into 1 upon r, because 1 upon infinity, this become 1 upon infinity is equal to 0. Then W is equal to, you can write this: W is equal to q upon 4 pi epsilon naught q. This is a electrostatic potential at point A due to charge, here charge q is given by this total work done W replaced by V, that is electrostatic potential q upon 4 pi epsilon naught into r. Consider equation 5th here. Equation 5th gives an expression for electric potential due to point charge. Note here: positively charged particle produce a positively electric potential, and negatively charged particle produce a negative electric potential. At infinity, r at r is equal to infinity, then we can write V is equal to q upon infinity. Then we dividing some term, V is equal to q upon infinity, we gives potential is electrostatic potential become 0. This is shows that the electrostatic potential is 0 at infinity. Then another one: for any point at a distance, small r from the point, charge is q, the value of V is the same and is independent of the direction. Hence electrostatic potential due to single charge is spherically symmetric. Here given graph variation of electric field and potential with a distance small r. See this graph. Along y-axis we given here variation electric field denoted by E and electric potential V, and along x-axis distance we consider small r, and this nature shown in this graph here, V and E. Then we can note some points here. Due to a single charge at a distance small r, due to a single charge at a distance small r, then force, that is capital R, or electrostatic force F, inversely proportional to the r square. Second, electric field capital E, inversely proportional to the r square, and electric potential V, inversely proportional to the r. This is a significant of this variation of electrical field and potential with distance. This distance we consider small r. Some question asked on this topic. Obtain the obtain an expression for electrical potential due to a point charge. Then we discuss second point, electrical potential. Second point, electric potential due to a electric dipole. Electric potential due to an electric dipole. Consider an electric dipole. Let's origin be at the center of dipole as shown this figure. See this diagram. This is a electric potential due to an electric dipole. Let capital C be an any point near the electric dipole at a distance. We consider here a distance small r from the center of O, inclined at an angle theta. Inclined at angle at theta here with axis of the dipole. Let r1 r2 be the distances of point C, capital C, from charges plus q and minus q respectively. Potential at C due to a charge plus q, here plus q, we can calculate plus q at capital A is given by here, potential at C due to charge plus q at capital A is given by V1 is equal to plus q upon 4 pi epsilon naught into R1. Consider equation first here. Then we calculate next point here, potential at C due to point minus q at B is, we consider this potential V2 is equal to minus q upon 4 pi epsilon naught, and this distance consider R2, q1 upon 4 pi epsilon naught R2. Consider equation second here. But the potential at C due to dipole is given by here, V suffix C is equal to V1 plus V2. Then equation first and equation second put in equation third, we gets V suffix C is equal to plus first we calculate here V1 plus q upon 4 pi epsilon naught into R1 plus V2 become minus q upon 4 pi epsilon naught R2. Then rearranging this equation, we can write uh, v suffix c is equal to q upon 4 pi epsilon naught is common term, take outside the brackets. V suffix c is equal to q upon 4 pi epsilon naught into 1 upon r1 minus 1 upon r2. Consider equation 4th. By geometry we can see here r1 square is equal to, see this diagram, r1 square, here r1 square, and here, then we can write here by geometry we can write here r1 square is equal to r square plus l square minus twice RL into cos theta, this equation. Then r2 we can write here r2 square is equal to r square plus l square plus twice RL into cos theta. Rearranging this equation, we can write r1 is equal to r2 square into r square upon r square plus l square upon r square minus twice RL upon r2 square into cos theta. Then we can write this r1 square is equal to r square into 1 plus l square upon r square minus twice l upon r into cos theta. Then similarly we can write r2 square here, take r square outside the bracket, r square is equal r2 square is equal to r square in bracket 1 plus l square upon r square plus twice l small l upon r into cos theta. Here for a short dipole, here a short dipole, twice l less than r, here twice l less than r, and if small r greater than small l, then we can write here small l upon r is very small, then l square upon r square can be neglected. Then this equation we can write this r1 square is equal to r square into 1 minus twice l1 upon r square into cos theta, and another equation r2 square is equal to r square into 1 plus twice small l upon r into cos theta, because here l square upon r square can be neglected. Consider equation 5th here, taking square root of equation 5 we gets r1 is equal to small r into 1 minus twice into small r upon small l upon r into cos theta raised to 1 by 2, and r2 we can write small r into 1 plus twice l upon r into cos theta raised to 1 by 2, because we taking square root of equation 5. Here taking reciprocal of equation 6 we gets 1 upon r1 is equal to 1 upon r into 1 minus twice small l upon r into cos theta. Then reciprocal of 1 by 2, we take here minus 1 by 2 here, and 1 upon r2 is equal to 1 upon r2 is equal to 1 upon r into 1 plus twice small l upon r into cos theta raised to minus 1/2. Consider equation number 7 here. Then put equation 7 in equation 4, we get v suffix c is equal to q upon 4 pi epsilon naught. We can write 1 upon r1 minus 1 upon r2. Then v suffix c is equal to q upon 4 pi epsilon naught into 1 upon r into 1 minus twice l cos theta upon r raised to minus 1/2. Here minus 1 upon r into 1 plus twice l cos theta upon r raised to minus 1/2. Using binomial expansion, we know that here 1 plus x raised to n is equal to 1 plus nx, 1 plus nx, then x less than 1 and retaining term as to the first order of 1 upon r only. We get here v suffix c is equal to q upon 4 pi epsilon naught 1 upon r into 1 plus small l upon r into cos theta minus 1 minus small l upon small r into cos theta. Rearranging this equation, we can write this v suffix c is equal to q upon 4 pi epsilon naught r. Here plus 1 minus 1 gets cancelled, small l upon small r into cos theta, and here remaining plus small l upon small r cos theta. When adding this equation, we can write v suffix c is equal to q upon 4 pi epsilon naught into small r into twice l cos theta. Therefore v suffix c is equal to q upon 4 pi epsilon naught into r. We can write this twice l cos theta upon r. Then v suffix c 1 upon 4 pi epsilon naught into r into rearranging this equation, we can write this q into twice l into cos theta upon r. Then v suffix c is equal to 1 upon 4 pi epsilon naught into p into cos theta upon r square, because here p is equal to q into twice l. This equation 8 gives the expression for electric potential due to an electric field. Then electric potential at C can also be expressed as v suffix c is equal to 1 upon 4 pi epsilon naught into p bar into r bar upon r cube. Okay, v suffix c is equal to 1 upon 4 pi epsilon naught into p bar into r bar upon r cube. This equation we can write in this way: v suffix c is equal to 1 upon 4 pi epsilon naught into p bar into r cap upon r square, because here r cap is equal to r bar upon small r here. R cap is equal to r bar upon small r here. Then here small r cap is a unit vector along the position vector. OC bar is equal to r cap. Then we can calculate here we discuss here some special cases. First here, potential at an axial point. Axial point here theta is equal to 0. Theta is equal to 0 degree. Here this toward the plus q or 180 toward the minus q. Then axial potential V axial is equal to plus minus 1 upon 4 pi epsilon naught p upon r square. This is maximum value of the potential. Maximum value of the potential. And a second case or second case here, at an equatorial points, this potential at an equatorial points, this here theta is equal to 90 degree and v is equal to 0. Take this value, v suffix c is equal to 1 upon 4 pi epsilon naught p into cos 90 upon r square. Here cos 90 becomes 0. Then v suffix c 1 upon 4 pi epsilon naught p into 0 upon r square. Then v suffix c is equal to 0. Hence the potential at any point on the equatorial line of a dipole is 0. This is the minimum value of the magnitude of the potential of a dipole. Some question asked on this topic: derive or obtain an expression for electric potential due to an electric dipole. We can do here electric dipole v suffix c is equal to 1 upon 4 pi epsilon naught into p into cos theta upon r square. And third point we can discuss here. Third points: electrostatic potential due to an system of a charges. See this diagram. Consider a system of n charges. Here q1 first, q1, q2, q3 and q1 up to qn at distances. First we consider r1, r2, r3 up to rn respectively from point p here. Shown this figure system of charges. Let the potential v1 at point P due to charge q1 is given by, we can write v1 is equal to 1 upon 4 pi epsilon naught into q1 upon r1. Consider equation first. Similarly we can find potential at point due to a charge q2, q3, q4 up to q1 are given by v2 is equal to 1 upon 4 pi epsilon naught q2 upon r2, and v3 is equal to 1 upon 4 pi epsilon naught q3 upon r3. Consider equation second here. Consider equation second by the superposition principle of a charges. Superposition principle, we can write this v is equal to v1 plus v2 plus v3 plus up to plus vn. Then v1 we can write 1 upon 4 pi epsilon naught q1 upon r1. Then v2 we can calculate 1 upon 4 pi epsilon naught q2 upon r2, and v3 1 upon 4 pi epsilon naught q3 upon r3, and vn we can calculate 1 upon 4 pi epsilon naught qn upon rn. Put this equation in that equation we get v is equal to 1 upon 4 pi epsilon naught q1 upon r1 plus 1 upon 4 pi epsilon naught q2 upon r2 plus 1 upon 4 pi epsilon naught q3 upon r3 plus up to plus 1 upon 4 pi epsilon naught qn upon rn. Then eastern 1 upon 4 pi epsilon naught is constant term, then take outside the bracket. This become v is equal to 1 upon 4 pi epsilon naught remaining hot q1 upon r1, next q2 upon r2, next plus q3 upon r3 plus up to dot dot plus qn upon rn. Then q1 upon r1 plus q2 upon r2 plus q3 upon r3 plus up to dot dot plus qn upon rn. We can write this summation of these charges. Then here v is equal to 1 upon 4 pi epsilon naught 1 upon 4 pi epsilon naught into summation changes from uh, I is equal to 1 to n and q suffix I upon uh, r suffix I. Consider equation third. This equation third gives electrostatic potential due to a system of a charges. Some question are on this topic. Obtain an expression for electric potential due to a system of a charges. Obtain an expression for a electric potential due to a system of a charges. In this way we complete 3 point electrical potential due to a point charge. Another one electrical potential due to electric dipoles, and third point electrical potential due to system of a charges. Today we stop here. Thank you.